Have you ever wondered how everything around us, everything we know, came to be? It's a question that has puzzled us since time immemorial. The origin of the universe. This vast expanse of space that we call home is filled with galaxies, stars and mysteries waiting to be unraveled. It's a story that spans billions of years, a story of cosmic proportions. So let's embark on this journey together, exploring the farthest reaches of our understanding. The story of the universe is a tale of time, space, and a lot of mystery. Our story begins about 13.8 billion years ago with a momentous event known as the Big Bang. This wasn't an explosion in the traditional sense, but rather an eruption of sheer energy, a sudden and violent expansion of space itself. Imagine, if you will, the entirety of what we now understand as the universe compressed into an infinitesimal point, a singularity. Then, in an instant, this singularity begins to expand. This is the Big Bang theory. It's our best explanation for the origin of the universe, as it accounts for the observations that the universe is expanding and the cosmic microwave background radiation that permeates all of space. In the aftermath of the Big Bang, the universe was a hot, dense and chaotic soup of particles. It was filled with photons, neutrinos, electrons and baryons, which are particles like protons and neutrons. These particles were constantly colliding and interacting with each other in a state of extreme energy and density. As the universe expanded, it also cooled. This allowed the particles to slow down and eventually form the first atoms. These were primarily hydrogen and helium atoms, the simplest and lightest elements. These atoms didn't form immediately, though. It took around 380,000 years after the Big Bang for the universe to cool down enough for this to happen. The formation of these atoms was a game changer. Once they were around, they could clump together under gravity to form clouds of gas. These gas clouds were the seeds from which everything else in the universe grew. They would eventually collapse under their own gravity to form the first stars and galaxies. And thus the universe as we know it was born. From this primordial soup of particles emerged the building blocks of the universe. The first stars and galaxies began to form from these particles about 300 million years after the Big Bang. This was a time of immense transformation, where the universe, once a dark and formless expanse, started to take shape in a spectacle of light and energy. Imagine the universe as a cosmic dance floor, where particles are dancers, constantly moving and interacting with each other. Gravity, the unseen choreographer, pulls these particles together, forming dense clusters. Over millions of years, these clusters grow denser and hotter until they ignite, giving birth to the first stars. Stars are the heart of galaxies. They are not only sources of light and heat, but also the cosmic forges where elements heavier than hydrogen and helium are created. At their core, the intense pressure and temperature set the stage for nuclear fusion, a process where hydrogen atoms combine to form helium. This process releases a tremendous amount of energy, causing stars to shine brightly. But stars are not eternal. They have a life cycle. They are born, they live, and they die. And it's in their death, particularly for the massive ones, that they play a crucial role in the grand scheme of the universe. In the explosive end of their lives, known as a supernova, these stars scatter their enriched guts across the cosmos. These stellar remnants, containing elements like carbon, nitrogen, oxygen and iron, are the raw materials for new stars, planets and eventually life. So when you look up at the night sky and marvel at the twinkling stars, remember that each one is a cosmic factory, a beacon of energy, and a harbinger of life. They are testament to the universe's ability to create order from chaos, to transform raw, formless matter into complex systems of breathtaking beauty and intricate design. Stars, through their fiery deaths, created the elements necessary for life. We are all, in essence, made of stardust. Among the billions of galaxies in a quiet corner, our own solar system began to form. Born from a colossal cloud of gas and dust, known as a nebula, roughly 4.5 billion years ago, our cosmic neighborhood started to take shape. The nebula began to collapse under its own gravity, causing the material at its core to heat up and form a protostar. This was the birth of our sun, the heart of our solar system. As the protostar continued to amass more material, it grew hotter and denser, eventually igniting nuclear fusion at its core. With this, our sun began to shine, providing the warmth and light that would one day support life on Earth. Around the newborn sun, the remaining dust and gas began to coalesce into a flat disk. Within this disk, smaller particles began to stick together, gradually forming larger and larger clumps. These clumps eventually grew into planetesimals, the building blocks of planets. The inner solar system, where temperatures were high, saw the formation of rocky planets: Mercury, Venus, Earth, and Mars. These terrestrial planets were formed from heavy elements that could withstand the intense heat of the young sun. Further out, where temperatures were lower, the gas giants, Jupiter, Saturn, Uranus, and Neptune, began to form. These planets, composed primarily of hydrogen and helium, grew massive enough to capture large amounts of these light gases, resulting in their enormous sizes. And then there was Earth, our home. Earth, with its moderate distance from the sun and its solid surface, was just right for water to exist in liquid form. This water, along with the right combination of elements and energy from the sun, set the stage for the evolution of life. Our solar system, a cosmic dance of planets around a central star, is but a tiny part of the vast universe. Yet, it's a testament to the incredible processes that shape galaxies, stars, and planets. On one of these planets, Earth, conditions were just right for life to evolve. So here we are in an ever-expanding universe filled with countless galaxies, stars, and planets. We live in a cosmos that is constantly changing, growing, and evolving. As we speak, stars are being born and dying, galaxies are colliding and merging, and new planets are forming around distant suns. Our universe is in a state of perpetual motion and transformation. The universe as we know it is expanding. This isn't just a theory or a hypothesis, it's a fact confirmed by countless observations. The galaxies are moving away from us and from each other, carried by the fabric of space itself as it stretches out. This expansion began with the Big Bang, some 13 to 14 billion years ago, and it continues today. But what does the future hold for our universe? There are many theories, and while we can't predict with certainty, we can make educated guesses based on our current understanding of the cosmos. One possibility is the Big Freeze, a future in which the universe continues to expand until it becomes so vast and so cold that stars can no longer form. Another is the Big Crunch, where the expansion of the universe eventually reverses and everything falls back into a single point. There's also the Big Rip, where the universe expands so rapidly that galaxies, stars, planets, and even atoms are torn apart. However, these are all just possibilities. The future of the universe is still largely unknown, and that's what makes it so fascinating. The cosmos is a grand mystery, a riddle that we humans are just beginning to unravel. As we gaze into the night sky, we're not just looking at stars and galaxies, but we're looking into the past. And as we look to the future, we're faced with endless possibilities, countless questions, and infinite unknowns. The universe continues to evolve, just as it has for billions of years. And as long as there are stars in the sky, there will be those who look up and wonder, what's out there and what's next? And that, my friends, is the beauty of the cosmos. The universe, from the Big Bang to the present day, is a story of creation and evolution. This narrative begins with the Big Bang, an explosion of unimaginable scale that marked the birth of our universe. From this fiery origin, the universe cooled, expanded, and eventually gave rise to the first galaxies and stars. These celestial bodies, in turn, served as cosmic forges, churning out the elements that would later make up the planets, including our own. Speaking of which, our solar system, a cosmic whirl of planets orbiting our sun, is but a speck in the grand tapestry of the universe. It was born from the remnants of stars long gone, in a process of stellar recycling that underscores the cyclical nature of the cosmos. And what of the universe today? It's a vast, ever-expanding expanse of galaxies, stars, and celestial mysteries. As we continue to peer deeper into the cosmos, we uncover more about its past and gain insights into its future. From the detection of gravitational waves to the discovery of exoplanets, the universe continues to surprise us, challenging our understanding of physics and cosmology. As we look up at the night sky, we are seeing the history of our universe unfold before our very eyes. And who knows what mysteries are yet to be discovered. The universe is a grand, ongoing story, and we are privileged to be a part of it. Here's to the mysteries yet to be unraveled and the knowledge yet to be gained.